Excellent. The slide that was there before, can that go back up? Or was that something I do? Excellent. So, yeah, welcome everybody. So Laurent and myself, oh, hello. This is Tara, our non-digital mascot. She barks at people she likes, so feel gratified if she barks at you. Yeah, so welcome. So Laurent and myself, I'm Charlie Wilson. We have put together this session on digitalization. The reason is summarized in this little box on the left, that digitalization, I hope we will all agree, is this megatrend that is reshaping life in many aspects as we know it. And yet, it is almost completely invisible in long-term scenarios and pathways. It's not mentioned once in the chapter 3 of the recent IPCC report, and it's only mentioned once in the original Brian O'Neill narratives paper around the SSP. So a big missing element. So we've got 3 talks that are going to explore this, and the first one is a joint talk by myself and Felix Kreutzig, which he's not here. I don't know if he's online, but we pre-recorded it for the online version. So we're going to play that one because you get both of us doing this sort of slightly bad comedy act, and then we'll move on to the other presentations in the room. Oh, and that's right, there's Tim, who's going to give his presentation by remote after us. So, oh yeah, hi Tim, we've just started the session. We're going to play one talk for 10 minutes and then it's over to you, I think. But stay online, don't go anywhere. Great, could we play
Thanks, Charlie.
Play the first movie?
Hi, let me introduce Charlie, who is the good guy today.
And my co-conspirator Felix is going to play the role of the bad guy as we discuss digitalization in the Anthropocene. So by way of context, 2 obvious statements: digitalization and climate change are megatrends that will shape life in the Anthropocene. And by digitalization, we essentially mean collecting, exchanging, storing, processing data quickly, connectively, and cheaply.
One of the main hypotheses that we have is that digitalization is a continuation of information systems. And one of the earliest information systems is script, like the cuneiform script from Sumer, where the first signs were used to communicate messages to organize dam building, which led to the first ecosystem catastrophe by flooding and desalination problems.
Fast forward several millennia, skipping over major new information systems involved in both the agricultural and also industrial revolutions, and we come to the differential analyzer developed at MIT in the 1920s, which was also used as an analog model of the expanding electricity grid at the time.
So, from a historical perspective, digitalization is just the latest generation of information systems. It impacts natural human systems by increasing efficiencies, which is very important. It makes our lives much more efficient and enables us to get new options. With that, of course, there are new forms of consumption coming in, and that means also growth, and actually growth in resource use and overconsumption in also relation, of course, with respect to greenhouse gas emissions. And it leads to expanding political or economic control in time and space. In historical times, you just had access to a few people that you could control. By now, with Facebook and Google, you control many billions of people. It influences social interaction and cohesion, but also has the risks of polarization.
So in the 1950s, various digital innovations from to do with sort of signal processing, and then obviously the birth of what would then become the internet, were associated with what is known as the Great Acceleration that you can see in these trends. And this was the beginning of the Anthropocene.
Digitalization has 3 pathways. First, it influences planetary stability directly by direct and indirect environmental footprints of digitalization and AI, and by also having an impact on solutions by reducing possibly some options. It has 2 important other indirect pathways that are often overlooked. Digital technologies have impact on equity, sometimes positive, but also in major labor markets like the US, negative equity impact. And equity is important because only in more or less equal societies you have enough political stability that you can actually implement climate change policies, for example. Same is true for the third pathway, political agency, because if there is a lot of polarization that hinders deliberation and the development of own opinions that contribute to political debates, and in polarized societies, again, you have difficulties to actually implement climate policies.
And maybe worth pointing out for our audience, Felix, that these three criteria, planetary stability, equity and political agency, are the criteria by which we're evaluating the role of digitalization in the Anthropocene.
Thanks for reminding me.
It's a pleasure. So on to the first, equity. The implications of digitalization for equity, at least on the sort of negative side of the ledger, can be seen in this map, which represents the very uneven access to digital infrastructure and services which we see worldwide. And in the little photo you see towards the bottom left, with all of the e-waste, the electronic waste, digitalization is creating demands for all sorts of rare earth metals and other types of minerals which can have adverse local impacts on mining populations, again, particularly in the global south. Moving on to human agency, thank you for the reminder. I must remember my role as good guy, that on the left you see a whole variety of, if you like, agency enhancing roles of digital services, from access to finance, to livelihoods, again particularly in global south, to the ability of communities of interest to get together, to form and to create networks. However, it's not only a rosy picture.
It's actually a very dark picture, I would argue. The problem is the monopolistic data platforms, and they create a system sometimes called surveillance capitalism. There are three issues here. The first one, A, is that they get more and more powerful by more and more data agglomeration. They collect more data and it makes them more powerful, and they can collect even more data. That's just an intrinsic cycle, but it has influences on two other pathways. First, B, which is exercising behavioral control. It's a lot of nudging that is happening in social networks and influencing populations on a massive scale, which would be unacceptable if it would be done by democratic societies. And of course, pathway C, it influences political digital agency by specifically nudging into political opinions, which is done by polarization and like issues like Cambridge Analytica also directly for elections. So here I see a very, very dark form of how digital control is developing.
That's pretty bleak, Felix. I'm somewhat scared to know what you're going to think about the impacts of digitalization for the environment.
You won't be surprised, it's rather bad. But first, there are direct effects, which is really about the direct carbon footprint, for example, of digitalization. Currently, we are speaking about at least 1% of global greenhouse gas emission coming from data centers, for example. It's increasing exponentially. I have to admit, there are also a lot of efficiency technologies to make data centers more efficient. However, recent trends show that efficiency development can't keep up with the pace of demand for data centers. So not nice, but also it's not the largest point. There are a lot of indirect effects, which is really about like accelerating consumption, for example, by targeted advertisement, and which really means that there are a lot more consumption interactions that are not responding to human needs, but they are responding to increasing carbon footprints. And worst of all, there are systemic effects. There are full changes on societies. I mentioned polarization. Yeah, I have to admit, sometimes they could also develop in nice directions. For example, you can integrate renewables much better by digital devices.
Taking a little bit more of a positive spin on that, Felix, I would say that certainly those latter green positive effects on systemic change are actually, as you say, fundamental to future renewable grids which will rely on highly complex real-time balancing of distributed loads, storage and supply.
I don't mind what you're saying, but I would prioritize it. It's even more important to prohibit the bad red effects, so to put it under regulation.
So what we stimulate and what we prohibit going forward is the final part of our talk, in which we shift to the scenario context. What does the future hold?
I think you can be the bad guy now.
Oh, okay. So think about where we are with emissions now, and think about our three criteria that you see on the right for life in the Anthropocene. If we don't get a handle on these adverse effects of digitalization that Felix, largely on the bleak side of the ledger, was describing, then it doesn't look good. Digitalization could induce consumption through both rebound and intensification effects, increasing the scale of our energy and material reliance from digital infrastructure, and adversely affecting the criteria for life in the Anthropocene. So what about the good story?
The good story is that actually digitalization can help rapid decarbonization, and it does it by two different pathways. The first one is acceleration of innovation so that new technologies come to the market much faster. And the second pathway is actually that there are new systemic efficiency gains by adding actually new options, for example, using shared mobility systematically and avoiding private car use. However, even there is a bit of a dark side, because some of these aspects could be implemented such that decarbonization works, but at the same time equity and political agency is still having a bad outlook. So the challenge is to have decarbonization, but at the same time look for equity effects and also to have positive impacts on political agency.
So that gap between the red undesirable and the green desirable is ultimately the space in which directing digitalization for public purpose has such critical role to play. So over to you, Felix, for the final word to describe this critical policy agenda.
No, I think you should do the planetary boundary ones.
Okay, fair enough. So from the climate change perspective, from the greenhouse gases, we know the importance of reducing both the energy and the material footprint of digital infrastructure. Circular economy measures will play a critical role there. We know also that ever more profligate ways of using digital technologies are continually being developed. Bitcoin is one that exercises a lot of people's anger, if you like, in terms of its energy profligacy. So the Royal Society in the UK have proposed something called an energy proportionality test, against which we would judge the worth of new digital applications. There are also lots of things that can be done around open data for public purpose to help optimize and design efficient systems, as well as encouraging or requiring digital service providers to account for supply chain emissions of their digital services, enabling both informed consumer choice as well as distinguishing policies. But what about the human agency and equity stories?
It's equally important, and you do have...
I wanted to have the last word, so I wanted to cut off before people. So apologies, when we pre-recorded it, we weren't quite as time constrained as we are now. So I'm just going to, hopefully you had a chance to read those final bullets about how we try and address these issues. We're going to move straight on to the next two talks and to try and keep as much time as possible for discussion. So, Tim, are you online and ready to speak?
Yes. Hi, Charlie. Yes, thanks for that presentation. You just went a little bit quiet at the end there.
Okay, let me just cue up your slides. Hold on 1 minute. In fact, can someone who knows how to work a PC quickly come? I can't remember how to do it.
Yeah. So I've also pre-recorded my slides on the.
I think we'll. Yeah. No. But can we switch over to Tim's slides? I can't remember how to use a PC. Digitalization. Captain of the Mac universe. Do you show the slides?
I can show the slides.
Brilliant. Yeah, Tim Foxon presentation. So I think, Tim, the way it works is that you'll speak and just say next slide and we'll move them on in the room. But just hold on 1 moment.
Okay. Sorry, you're a little bit quiet, Charlie. I don't know if it's the microphone or...
Other microphone. Sorry, Tim, I had the wrong microphone. I think we're going to show the slides in the room and just say next slide when you want us to move on. But just hold on 1 moment while we get them queued up.
Okay. As I say, I recorded the commentary with them, so you might get the...
Oh, I see. I think we've just got the slides, not the thing.
Okay.
While we're waiting, does anyone have like a sort of clarification type question for the talk you've just heard? Not a big substantive one, but anything that was unclear? Everything's radiantly clear. Excellent. Yes, we've got two more talks, and then we're trying to keep...
Good afternoon. I'm Tim Foxon from SPRU, the Science Policy Research Unit at the University of Sussex, and reporting today on work we've been doing with my colleague Noam Bergman on the looking at pathways for the impacts of digitalisation on energy demand. So this is part of the work under the Digital Society theme of the UK Centre for Research on Energy Demand Solutions, CREDS. So initially we undertook an analysis of UK and global net zero scenarios to identify a range of impacts of digitalisation on energy demand, including direct impacts, indirect effects, which could include efficiency improvements, but also rebound effects and impacts on economic growth. We're now, in the second part of the work, examining different pathways for digitalization and how these can impact on energy demand. So the key messages from the review of low carbon scenarios, as I'm sure others will have said as similar things, an increase in the number of and usage of ICT devices will drive an increase in energy demand. Efficiency improvements, substitution of physical by digital services, and ICT enabling behaviour change could drive reductions in energy demand, but these can be offset by stimulating increases in the demand for these services. So, for example, work done by our colleagues at SPRU, Bernardo Cardarolo and Steve Sorrell, showed that while teleworking, working from home, can reduce the number of commuting trips, it can potentially lead to increases in energy demand through increasing the distance of the commute and also stimulating non-work trips. So there's also the potential for stimulating economic growth through productivity improvements, which could lead to overall rises in energy consumption, and automation could lead to increased job losses and increasing inequality. So pathways for digitalization matter, and net zero scenarios don't pay enough attention to digitalization, and particularly the drivers of the underlying energy demand, the political choices, and questions of the plausibility of technical and social assumptions. Some examples of the type of effects we found in these scenarios: an expectation of a huge increase in the number of ICT devices in coming years. This could partially be offset by saturation in the global north. There's only a limited amount of time actually people can spend online, and or integration of different devices into one device, such as smartphones, as Arnold Grubler looked at in his global low energy demand scenarios. Efficiency of devices is improving, but embodied energy, the energy used in production, is an important part, particularly as the energy use improves. So rapid innovation cycles can increase efficiency, but longevity and repairability of devices can reduce the embodied energy effect. But in work with Lawrence Williams, we showed that scenarios looking at the impacts of 5G networks on energy demand generally don't take embodied energy effects into account. Intensity of use is also increasing. Cloud computing, for example, requiring more data centers and other infrastructure using more energy. So, as I say, what we want to do in the second part of this work is to combine this with work on my colleagues in CREDS, led by John Barrett from the University of Leeds, looking at UK low energy demand scenarios, and their work drew on Arnold Grubler's and others' work at the global level, and looked at assumptions across different narratives for assumptions across different economic sectors within the UK, and combined this with system modelling of those sectors. And they showed that it was possible to achieve a 52% reduction in UK energy demand from 2020 by 2050 in the most ambitious transform scenario. And one of the drivers of this was the number of high-level trends, and digitalization as one of these high-level trends driving energy demand. So in this ambitious transform scenario, there are a number of specific assumptions about how digitalization could help to reduce energy demand. For example, the capture and use of energy system data, enabling energy system providers to more efficiently meet users' needs, and to enable consumers to improve their control over their own energy use, and hence leading to reductions in energy demand. looking at substitution of digital services for material goods, for example, digital books, digital music provision, and so on. Again, digitalization in transport and mobility provision, enabling remote working and remote interactions, and a shift towards shared mobility, public transport, and walking and cycling solutions. And also enabling sharing and circular economy solutions, so designing for repair and reuse rather than single-use goods. But of course, realizing these energy savings, the scenario assumes that these energy savings can be realized and are not significantly reduced by rebound effects. So it's clearly where the governance of the pathway of digitalization is important, and how that interacts with the drivers for net zero. What we're doing now, we're arguing that realizing these transform scenario, these ambitious energy savings, requires governance to promote what Newsign and Tagliapietra called responsible digitalization. So rather than a selfish, individualized pathway for digitalization, in their work on transport, they emphasize this responsible digitalization pathway, emphasizing these shared solutions and community benefits. And from our work on scenarios, this could include focusing on empowering users and providing information rather than just focusing on automation and circumventing users, looking at new business models, for example, focusing on data as a common good or digital commons, rather than leaving power in the hands of a small number of superstar companies, and an increased focus on pathways that incorporate social well-being and environmental protection as key attributes from the start, rather than merely green growth pathways that promote economic growth and the social impacts social and environmental impacts to be sort of cleared up later. Now, clearly, there's action now at the EU level, particularly to start to regulate the adverse social impacts of digitalization through, for example, the Digital Markets and Digital Services Act, but so far little attention to energy and carbon impacts, or looking at digitalization in a systemic way to promote the potential for social and environmental benefits, rather than a narrow focus on economic benefits. So I'll leave it there. Thank you.
Excellent. Many thanks, Tim. And apologies, we ended up playing your pre-recorded version, but you came across loud and clear in the room. While Benedict gets set up for the final talk, does anyone have any quick technical questions for Tim? We'll have discussion at the end. Okay, excellent. So we'll move straight on with our final speaker, who Benedict is going to talk about governance. Do I need the microphone? Yes. That one just doesn't work. No.
Thank you. Can we get the slides up? Well, first of all, yeah, I started the presentation, but doesn't show up here. I've got the presenter's view. Thank you. Yeah, we also prepared a video, but I'm going to try to do the presentation myself. I'm here on behalf of myself and Doris Fuchs, who sadly couldn't be in Vienna this week. I hope she feels well enough to follow online. And with that, let's get started. In our paper, we focus on research with the question which narratives on the relationship between AI and sustainability can be identified in AI regulation. And as you'll see during the course of the presentation, there is some overlap with the two presentations we just saw. We focus on narratives as a central point because they help to sort of set the stage for what regulation can entail. They order the world and show what can be imagined, and therefore shape the realm for regulation and sort of the corridor in which regulation occurs. We do that by identifying the narratives in a systematic literature review, and then we take the results of that literature review and apply that to a content analysis of relevant regulation, and in this case that'll be the European Union and the United States. Now, when we talk about narratives, they can be transported in many ways, for example, through pictures. And one very common narrative is concerning artificial intelligence, likens artificial intelligence to human behavior. And one way that is transported in pictures is by taking a head or a brain and filling it with a sort of a circuit board or machinery. Whereas other pictures that transport potentially different narratives try and maybe focus more on a technical side and try to show examples of visual analysis, or the top picture here on your right is an example of well, explainable AI, or a neural network, and how that can be explained. We identified a set of narratives on AI generally, which starts with the terms intelligence and learning as in machine learning, which sort of evoke human-like associations and liken the technology to human concepts and experiences. And then we have the personification of technology as a second narrative, which we often see in media, in many science fiction works. We have and with that goes the expectation of human-like or even more than human intelligence if we talk about the concept of artificial general intelligence. More concrete or more concrete are narratives on the inevitability of AI and the need for international competition, or the need for regions to position themselves in international competitions in a way that gives them an edge. And also the idea of them as highly disruptive technologies, which is something that we already heard in another talk, a technology that has impacts on all forms, or on all parts of the economy, and potentially all parts of society. Now, more narrowly, narratives on AI and sustainability can be grouped, or are grouped by Van Winsberge, in two categories. One is AI for sustainability, and the other one is the sustainability of AI. The former one focuses on how the technology as a tool can be used to improve the sustainability of societies through increases in efficiency in resource usage, whereas sustainability of AI tries to take a more broader approach and also incorporates different aspects of ecological and social consequences that might also have negative impacts. So just a quick overview, AI for sustainability focuses, well, can be grouped in three categories: environmental sustainability, which is resource optimization, as I said, research on smart cities, and AI for climate change, which is AI applications that can be used in modeling climate change. Now, on the other hand, we have sustainability of AI, which focuses on the need of developing AI in accordance with sustaining environmental resources for current and future generations. And as an example, the research usage by machine learning applications, for example, in natural language processing applications, can be very high. For example, the equivalent of the CO2 emissions or CO2 equivalent emissions of 5 cars over their entire lifetimes. And this data is not from 2022, but maybe 2 or 3 years old. So current numbers are likely even higher. And another factor is this, the social impacts of AI, because the benefits and negative impacts of AI technology are often very unevenly distributed among different groups of the population within a country, but also globally between the global north and the global south. For example, if you remember the map that we saw in our first presentation on the accessibility to digital infrastructure, that of course, if there's no access to that, a lot of AI applications also have no value to people that don't have that access. And finally, the role of public actors in regulatory oversight is mentioned in, or is a part of sustainability of AI, in order to, well, oversee the development and the sustainability of it. So just summing up quickly, these are the narratives, or the parts of narratives that we identified and that we then looked for in the regulations. So that's inevitability, competitiveness, disruptiveness, AI for sustainability. So AI as a function to increase sustainability, and sustainability of AI in terms of ecological implications and social implications. Now, we chose to start with regulation from the European Union and the United States because these are two of the three, or what are considered to be three major players in the field of artificial intelligence globally, the third being China, and certainly including the Chinese perspective would be worthwhile in future research, but we have not gotten there yet. Just a quick look at the results. Both regulatory frameworks are very focused on the idea of inevitability, on the need of competitiveness for the regions. But there's also a big difference between them, as the United States regulation is very much limited to that, in a sense. So there's no mention of the ecological implications. The question of AI for sustainability is mentioned in passing, as we should look into that, whereas the EU regulation goes into a little more detail on these questions. But especially ecological implications in the sense of energy demand and resource demand are only encouraged as voluntary measures for private actors. If we look on social implications, the difference is quite big. The EU has adopted an approach that tries to that is based on a risk assessment, where especially socially risky applications may be prohibited or may be subject to non-voluntary rules, whereas less risky applications are only ever subject to voluntary rules, whereas the US regulation again says we'll look into that in the future. And I'm looking at the time, and I'm about to finish. The privacy and data gathering regulations are very loose in both of them. The EU is again slightly more detailed in what they suggest, especially for post-market data gathering, and the international implications, which I think are very central in thinking about this in the future, especially when we talk about the AI supply chain, are not mentioned in either one, although the risk-based approach of the European Union may have international consequences, because these rules are true for all AI applications, regardless of where they've been developed. So international or non-EU companies may have to take those into account as well. All right, with looking at the time, I'll just quickly come to the conclusion and say, again, I'm not going to sum up what I just said. I think with a look to the future, it'll be interesting to see whether or not these considerations and this part of literature will find its way into regulation, and whether or not, as you said earlier, Charlie, scenarios will pick up on this and try to incorporate them. Thank you very much.
Excellent, many thanks, Benedict. Okay, so we've got about 10 minutes for discussion. Be very interesting to hear not just your questions, but also your thoughts or reflections on the role of digitalization in scenarios, as given where we are today. So does anyone have, and bear in mind also that hopefully my co-author Felix Kreutzig is online, as well as Tim Foxon, whose talk you heard is also online, so can answer questions. Oh, and sorry, and Zoe, yeah, sorry, and Laurent Drouet here, and Zoe, who's on the screen, are also co-hosts of this session. It was a sprawling session that got squeezed into 45 minutes. That's why it seems a bit, all a bit rushed. So questions or comments for any of us? Yes, is there another microphone, or we just got one? Just got one, okay.
Thanks, Charlie. Is it on? Yeah, okay. And thanks to all the speakers. This was really great, great material. Question for Benedict, but I wonder if it relates to the other two, the presentations before. Benedict, for these different regulations, were you able to, maybe you said this, but I may have missed it, were you able to figure out who was involved, which stakeholders were involved in the processes to develop these regulations on both the US and European side, and was this different? Because that could have an impact on pathways for utilizing digitalization as a force for good and not. But yeah, any comments on that? Did you want to take a few questions before? Yeah.
Yes, one here. Oh, sorry, one right next to you, and then one at the front.
Okay, so I think this distinction which we have heard from the last speaker, AI for sustainability and the sustainability of AI, is very, very interesting and very powerful because it's simple. I wonder whether Tim has, for instance, some plans to actually quantify this for the UK low demand scenario. what is the respective effect? I mean, I hear, you know, you want to look at the positive effects and the take-back effects, but where is the quantification? So is this planned, or is this just conceptualized but will never be implemented? So we will not have a case where we see what are the respective magnitudes of these different drivers. And I think this is an important complement of this, to find out which of these two tendencies might outweigh, and we might want to have different scenarios along this taxonomy in digitalization.
Yeah, to be quick, Henry Carlson, Stockholm Environment Institute. Thank you so much. So also to Benedict, when you presented the regulations, I tried to imagine being an inventor or running a AI research group, and I couldn't find anything I could not do. So it seems to be rather weak regulations, or are these just position papers or anything like that? Thank you.
So maybe let's quickly put those back. So a couple to Benedict and then one to you, Tim. Hopefully you heard that one around quantification.
Thank you. I think a part of this, I did not talk about the processes behind these, the regulatory processes because of time. They were different. The one from the United States was under the old administration as well. So that's something to take into account when people write these regulations. They'll try to write them in a way that gets them passed. So that's one thing to consider, and in a publication of this research we'll certainly go into more detail on how these processes worked and which stakeholders were involved. And then the second question on what was allowed and the things you couldn't do, I think I mentioned it quickly. For the European Union, there are certain applications that they can just prohibit. One example would be the credit score system, the social credit score system that is often referenced in that context. And for the United States, the regulation is focused on getting a competitive edge, so they don't have any prohibitions on that.
So Tim, if you're online, any response to the question about quantifying the impacts of different governance regimes over digitalization? Are you planning to do that? And if you're not, could you speculate as to what they might look like?
Sorry, unmute myself. Yeah, thanks for the question. Yeah, I mean, actually we're slightly working backwards because so the low energy demand scenarios for the UK that, as I presented, are fully quantified. So, as I say, they were using sector-specific models for energy supply, transport, food, materials, etc. And they were informed by the narratives, which included the narrative of digitalization and certain assumptions such as the increasing shared mobility solutions. What we're trying to do now is actually to dig more deeply into those assumptions around digitalization and what would be needed to realize them in sort of governance terms. So we have, as I said, within the scenarios, those impacts of digitalization have been quantified along with a whole range of other assumptions. So, and we're thinking about how to show more explicitly those impacts of digitalization, and particularly, as the other speakers have said, those choices for governance and regulation for digitalization. We, as I say, we are arguing that it will need much more explicit governance of the digitalization pathway to achieve those energy demand reductions which are included in these low energy demand scenarios.
Thanks, Tim.
Sort of answers the question.
Yes, thank you. Zoe, we can see you on the screen. Do you have anything you want to chip in or comments before we hand over to Laurent to wrap up? oh, pardon me, sorry. Laurent's just signalling that you'll talk alongside him in the room. So maybe we've got time for... Actually, no, we don't have time. Despite your wonderful quickfire questions, Laurent, who's the co-host, is going to offer some sort of reflections and thoughts on next steps in this topic for the community. And sorry, this was all very rushed.
Okay, thank you. So, yeah, from the presentation we had, basically I mean, now we have identified the challenges of digitalization, and there are many challenges. And one of them is that you need a lot of green lights so that digitalization benefits to society, going from the ICT skills to standardization to cybersecurity. There is a long list and so on. The second main challenge is that digitalization means more electricity uses and more material uses. And this comes as many places, many sectors, and also how you organize the network, what type of computing facilities you choose, and what type of end users devices. And you have to account also for the whole life cycle impact of the devices on the computer facilities. And the last challenges, which is very important, that digitalization has systemic impact. I mean, that was a bit very similar to one slide of your presentation. Basically, because you have a long-term socioeconomic reaction to digitalization. And also digitalization will bring some new service that we don't know what will bring to the society. Some maybe they don't bring anything, but some they will stay and change our behavior. So we need digitalization scenarios that basically encompass all these aspects of these challenges to assess what are the exact potential of decarbonization from digitalizations. So maybe we can go in some directions, like to have some augmenting scenarios based on the SSPs, starting from the SSPs. Having some new scenarios, but basically that span the range of the scale of these digitalization challenges that I mentioned in the slide before. But what we also really need is to have scenarios that speaks to different sectors, and that are integrated scenarios that speaks to the production of services and goods, to the consumption of end users, and also target also explicitly the ICT sectors to understand what is the evolution of the ICT sectors, and in consequence the energy supply, and then the material that are attached to the ICT sectors. So that's why to quantify we need we cannot do it without integrated assessment tools that encompass all these sectors somehow, if we want to understand exactly the systemic effect of digitalization. So Zoe will present like one modeling of scenario that we did in the Engage project.
Yes, thank you, Laurent. I mean, very quickly, digitalization is indeed one of the key pillars that were included together with climate change in the Next Generation EU and the Recovery EU funds. So indeed, this is a main mega trend that has huge implications also for the modeling community. And the main, let's say, research question that we had in Engage is whether digitalization aspects can actually form a type of game changer in mitigation. And here we assess digitalization in the mobility services. Most of you are very familiar with this concept, with the disruptive mobility trends, with electric vehicles, the sharing mobility, and the autonomous vehicles. And here what I mainly wanted to point out is that the modeling community has indeed very many data challenges. So electric vehicles have already been included in most of the integrated assessment models, but then coming to the shared mobility and the autonomous vehicles, there are many challenges in order to understand what is, for example, the new emissions profile, the occupancy factors of the vehicles, what what is the substitution between the different options of transportation, and again, in terms of social impacts, how to integrate, for example, in a CGE context, the impacts on maintenance, on saving time, etc. So what we saw here is a very simplified approach of including shared mobility in a CGE context, where the key focus is actually to understand the dynamics behind the choice of the users, and we model this through different types of costs: the actual costs linked to the purchase and operation maintenance of the vehicle, the fuel price, or the tickets, etc., and then the non-perceived or hidden costs that are related to the social status, the comfort, the environmental awareness. So all these are linked to, let's say, data challenges, and there we expect to have this interdisciplinary work between different fields of science to actually inform the modeling community.
Okay, thank you, Zoe.
Thank you very much.
Yeah. But yeah, we are very short in time, but thank you. I think we got a good insight from presentation. So thank you for attending the session on digitalization.
Maybe just very final point, the point that Laurent said about the need to look at digitalization in scenarios. Like we're hoping to kind of launch what would be lovely if it was a community effort. So if you're particularly interested in being part of that, then come and chat with us afterwards. But don't go anywhere now, because there's an amazing session on lifestyles coming up. And thanks for all our speakers and for all you for coming.
Thank you.
Yes, I have the honor to share this session on lifestyles. So the title of this session is Future Lifestyle Changes at Different Geographical Scales and in Response to Societal Shocks such as COVID-19. I am Daniel Johansson. I'm one of the co-hosts of this session. We are a range of co-hosts. It includes Charlie, that just was sort of the chair, and it includes Nicole van den Berg, Johannes Morfeldt, Jürgen Larsson, and Orlin Edelbosch. So it's a range of organizers. So we have 6 contributions to these sessions. 3 are posters. They are available online, so I recommend you to go to IIASA Connect and check the posters. And we have three talks here today, and the plan is to have sort of 10 minutes talk with short technical questions in between the talks, and then sort of a joint discussion for 5-10 minutes in the end. And we will start with Johannes Morfeldt, which will present his work on hybrid method for developing Swedish consumption-based emission scenarios.
Yes, great. So, hi. I am going to talk about first version of this hybrid method that we developed for Swedish consumption-based emission scenarios. And this is for sure a first version, but the interesting part was that the results were actually used in a political process to suggest consumption-based targets for Sweden, which was actually proposed by a government committee just a few months ago. Just to start off, to put us on the same page, what is consumption-based emissions? Here we see territorial emissions, which is the UNFCCC way of accounting emissions, which of course includes all the emissions within the border of a country. So in the Swedish case, you have emissions for products and services used and consumed in Sweden, but you also include emissions related to exports of products. But in the consumption-based perspective, you shift and instead you look at emissions still in Sweden that are used in Sweden, but you also include imports of other services and products and the value chains connected to them. And in the Swedish case, this is mostly focused on food products, some fuels, air travel, of course, which is per definition international, and there are also some materials that are traded back and forth. And the Swedish case is also kind of interesting here because the territorial emissions are around 5 tons per capita, while the consumption-based emissions are 9 tons per capita. So we have a big difference here that is based off of the fact that we're an open economy that trade a lot and import a lot of goods simply. Another important aspect is that of the consumption-based emissions, this part here is 36%. An additional 22% is traded within the EU, and 42% is from outside of the EU. And of course, there are different climate policies addressing these emissions that might be a motivation for why you want to have consumption-based targets. So you can also regulate this at a national level. To say just a few words about this political process, so it's a cross-party committee on the environmental objectives it's been around for 2 decades, that actually governs the environmental objectives in Sweden. And they were given a mandate from the Swedish parliament to propose targets on consumption-based emissions. And what I'm presenting here today is this report. You're welcome to scan the QR code if you want to read it. And this was commissioned by the committee, and it was actually used to kind of argue for their case. I'm going to come back to how ambitious their suggestion is in comparison to what we model. But just to quickly walk you through the analytical framework, I have short time, so I'll do it very quickly. We used simplified scenario narratives that are kind of built around current trends in different indicators as a reference scenario. Then we look at the territorial targets that are already in place in Sweden with a net zero target for 2045, and what the implications of that target would be for the consumption-based emissions. And then on top of that, we look at another layer of advanced technology, both in Sweden and abroad, and also lifestyle changes within Sweden. And all of this is to obviously then estimate the carbon footprint in line with the consumption-based definition. So we look at, on the one side, technology development in mainly transport, food, and housing, where we had specific models taking into account technological innovations and how fast technology would be disseminated in Sweden and in other countries. And on the other side, on the demand side, we look at demand growth, which is for the reference scenario based on government reports. And then also population projections, of course, and the lifestyle changes that we look at, which is, for example, less driving of cars, switching to a less meat-based diet, and reducing the square meter per capita in housing, for example. To then estimate the carbon footprint, I'll just skip a few things here. We do use the carbon intensities that are based on IIM results. So we use the International Energy Agency's scenarios for that to kind of show the difference depending on if the rest of the world develops in line with the Paris Agreement or in line with stated policies that are adopted at this stage. To continue into the results, this is the reference scenario, in which case it's the current trends, as I mentioned, and policies adopted at this point that governs the emissions. And we do have a slight decrease in emissions, landing at about 4 tons per capita. The interesting part here is that this is still based on demand trends that are increasing. So we are still pushing down the trend, even though we're at the current policy stage. And just as an example, this implies car travel per capita with an increase of 20% until 2050 compared to now, and 100% increase in air travel. And that also includes non-CO2 effects of air travel. Going on to if we only implement the territorial targets, so no care for the emissions that are imported, so to say. This would be mainly then from advanced technology as what is mainly promoted by the target as it is right now. Some of the main technologies are obviously a shift to electric vehicles, also fossil-free steel in the steel plants in Sweden, and so on. And here you can see the difference, which is kind of an uncertainty from the Swedish perspective. Depending on how the rest of the world develops, the result will be very different. So it ranges between 1.5 ton to just over 3 tons per capita, depending on the rest of the world, so to say. And I should also mention that the IEA scenario is a 1.8 degree mitigation scenario with net zero greenhouse gas emissions by 2070, so just to put it in context. If we instead only look at lifestyle changes, and the lifestyle changes we've looked at, we call them comprehensive. This is one thing that I want to work on more to get a better framing for it. But the idea is that it's lifestyle changes that don't impact welfare, so they would be like possible to actually implement. And it does include sharp reductions in meat consumption, for example, and transportation and housing. But we can see that only lifestyle changes would also not bring us very far, very low, and it's more or less in the same range as the territorial climate target scenario. But with a combination, we could push Swedish emissions down to around 1 ton per capita, assuming that the rest of the world develops in line with the Paris Agreement. And to give some examples of these lifestyle changes in numbers, for example, it would be a reduction of air travel by 50% until 2050 compared to today. Car travel would instead decrease by 20% instead of increasing by 20%. And this is actually in line with the trend. So even though the Swedish Transport Agency says that it would increase by 20%, it's been fairly stable per capita since the 1990s. And it also includes doubling of public transport and reducing beef and milk consumption by 75%, housing space by 10% per capita. So going back to the proposed targets by this government committee, what they propose is a net zero target, which is a very, I think, common way of defining targets on emissions at this point. But they propose a 2 to 3 ton target, depending on if they choose a 1.5 degree level or a 2 degree level. That's the range. And this is per capita then to 2045. And what we found, if we look at the 2045 mark, in the same, including the same parts of society, we would be on around 1 ton if you combine lifestyle changes and advanced technology. So there is the potential to actually push the ambition one more step compared to what was actually proposed from the Swedish cross-party committee. It's also interesting to note that the target would actually be reached if the territorial target is met and the world develops in line with the Paris Agreement. So it's not very ambitious, but on the other hand, it puts consumption and lifestyles on the kind of political map and makes it possible to discuss them in the future. I know I'm out of time, so I will do it very quickly, but I have some future ideas for future research, and it's partly to further develop like the framework for the demand side. So I have a better understanding of the lifestyle changes and put them in a more systematic framing. And the other thing that we're looking into doing is coupling the model that we've used with energy systems modeling, both to get a better estimate of the carbon footprint, but even also getting some impacts from, for example, European policies like Fit for 55 and what that would have as implications on these results. So that was it. Thank you.
Any short technical question to Johannes? Yes.
Thanks, very inspiring. Did you also study the policy instruments needed to make this lifestyle change happen? Yeah.
We haven't really gone into it in much detail, but we do look at some more detail in the report on what the actual measures would be that would get us there. But then exactly what type of policy it would be a next step to go into for sure.
Yes, so next speaker, we have a recorded talk. It is Hayley Steele from UC Davis. And have we got it up here on the screen? And the title of the talk, Should Future Scenarios Factor in Impact of Racism Upon Emissions? So, Hayley Steele, it should be in...
Hello, my name...
You are here? Oh, I didn't know you were here. Oh, because I was... So would you like to have your presentation? Yes. Yeah, if you, yeah, great if you are here. You would give it in person?
I'm nervous about but just stop me if I hit 10 minutes.
Yeah, but no problem. That would be great if you do it. I didn't know you were here, actually. I was trying to find you, and I got the information that you were not around. That's really great. So let's try to find your PDF instead, because now I open the video. And here is your... It's a PDF?
Yes.
I'm not used to it. Can you get it in presenter mode? You push.
Oh, I'm not sure.
Yeah. Yes, you can. Yeah.
Oh. And I think I might have actually left my notes.
That's great.
Okay, perfect. Precise language. So.
Yes, then I'll leave it to you. Great.
All right, perfect. Oh, thank you. All right. Yeah, thank you so much. My name is Samara Hayley Steele. I'm an advanced research affiliate at the UC Davis Mod Lab, which is a digital humanities laboratory. I worked with a number of co-authors on this talk, and I should say I'll probably be sticking to the script kind of closely because we did have to workshop the language for a level of care to cultural sensitivity for this, something that Jim Skia brought up in the plenary yesterday, you know, that is rather important when addressing certain topics. So that said, oh, interesting, it's a PDF. So in our review of research, our team found that racism, a study that confirmed that racism is a driver of emissions from on-road travel in the United States. And we concluded that it is time to study racism as a driver of emissions in a more general way. In this talk, I'm going to discuss current research supporting a limited understanding of the nonlinear relationship between emissions and racism, racism's effect on innovation and decision-making, racism's effects on energy policy and climate science, and I'm also going to offer a set of recommendations from our team. So, lately, a fair amount of research has received attention showing that communities and countries with the majority people of color populations emit less CO2 and cause less air pollution. Some quick examples. A 2019 study coupled economic input-output relationships to pollution emission sources in the US, exploring how the consumption activities of 3 groups, labeled Black, Hispanic, and White/Other, led to fine particulate matter, or PM2.5 exposure. The study found that Black people's consumption activities result in 23% less exposure to fine particulate matter than average, and that Hispanic people cause 31% less exposure than average. Meanwhile, those in the White/Other category cause 12% more exposure than average. Similarly, in another study, an economist worked to calculate excess CO2 emissions by country. The researcher calculated national fair shares of a safe global carbon budget consistent with a 350 ppm atmospheric CO2 planetary boundary, which was surpassed in 1990. This study looked at data from 1850 to 2015 using the pre-map, HIST, and Muro data sets, and also used per capita calculations to allow a country's population size to be factored in when determining its fair share of emissions. The researcher found that global north countries were responsible for 92% of global emissions exceeding the planetary boundary. While global south countries, which are more likely to have a majority, excuse me, to have a majority population people of color, while global south countries were more likely to have just 8% of all excess emissions. These two studies and many others show disproportionate rates of CO2 emissions and pollution being generated by communities and countries of color. Prior scenarios have explained discrepancies like these using deracialized measurements such as affluence and land use. However, there is data to support a more causal relationship between racism and emissions. We were able to find one 2018 study that used hybrid panel model analysis to test the effects of racial composition upon CO2 emissions in the United States across 3,079 counties from on-road travel between 2001 and 2006. Their findings include, firstly, that when the Black population in a county increases, that county's emissions also increase. Offering a theoretical explanation, the researchers posited that racist housing practices in the United States, such as redlining and gentrification, along with racist transportation policies that divert funding away from transportation in majority Black areas, led Black people to live in areas further away from their jobs, forcing longer commutes by car or the use of less efficient forms of public transport, like diesel-fueled buses. Conversely, when Black counties see an increase in affluence, their CO2 emissions from on-road travel decreases. The researchers controlled for a number of relevant factors, as you can see here. And there were limits to this study, though, including that it only looked at one category of emissions, emissions from on-road travel. But this study did show a non-linear relationship between populations that experience racist housing and transportation practices and CO2 emissions. This is to say, this limited study did find a relationship between structural racism and climate. Likewise, turning to another study, there was a 2020 Yale study that found people of color in the United States were more likely to be concerned about climate than white respondents. With 49% of white respondents showing alarm or concern about climate change, that number jumping to 57% for Black/African respondents and 69% for Latino/Hispanic respondents. White respondents were more likely to be doubtful or dismissive about climate change at a rate of 27%, whereas Hispanic/Latino respondents and Black respondents only showed an 11 to 13% expressed doubt or dismissiveness regarding climate change. Hispanic/Latino voters and Black voters were also more likely to rank climate change as an important factor in an upcoming voting decision than white voters. So looking at these numbers, at least within the context of the United States where this survey was taken, we can infer that systemic racism forces Black and Hispanic or Latino people from decision-making spaces, and that when it does that, the likelihood that the people in the room take climate change seriously decreases, and also the likelihood that people in the room are dismissive about climate change increases. Also, when Black and Hispanic or Latino people are denied access to voting in the US, the likelihood of electing policymakers who take climate change decreases, take climate change seriously decreases. So looking out more broadly at the effect of racism upon innovation and decision-making, there are a number of studies, mostly in the realm of psychology, that indicate ethnic diversity in groups improves decision-making, fosters greater innovation, and leads to enhanced information processing for everyone in the group, including those who are in the ethnic majority, and that the benefits can be stimulated by anti-racist practices and policies that promote systemic equality and inclusion. While there isn't time in this presentation to talk about all these studies, I will just hop over to one. There's this 2020 study that analyzed data from 3 decades of PhD recipients in the United States. They found that PhD students who are ethnic minorities innovate at higher rates, but their novel contributions are more likely to be dismissed, and they are less likely to earn academic positions. This is just one example of the research that shows how racism reduces innovation and removes innovators in every field, thus reducing society's overall capacity to address climate change. As for climate science and energy policy, In 2019, the University of Minnesota released a policy report entitled "Diversifying Leadership is Necessary for Climate and Energy." This report argues that structural racism fuels emissions in a variety of ways, including the concentration of social power and by limiting the potential for innovation. Likewise, in 2020, marine biologist and climate science policy writer Ayanna Elizabeth Johnson penned a Washington Post editorial exploring the ways racism and anti-Blackness have disrupted her own work and forestalled climate action. Quoting Toni Morrison, she writes, "The very serious function of racism is distraction. It keeps you from doing your work." In her editorial, as well as in an NPR interview, she explores how racism disrupts the ability of the very people who are statistically more likely to care about climate change from addressing it. So racism contributes to emission along a variety of fronts, from structural racism creating longer commutes in the US to preventing climate policy from getting written. What would it look like if our scenarios tracked the impact that racism will have on emissions in decades to come? So past studies have tended to focus on diversity rather than racism, or have been quite limited in scope. What if we were to use a similar approach to the way the impacts of sexism on emissions have been studied? Here's this study that looked at a variety of indicators, such as women's freedom of movement and ability to participate in civil society and hold leadership roles. What if we were to run a similar study to see if we can track a predictable relationship between emissions and racism using a variety of indicators across social domains? And the tools to create such a study, include, we found a few data sets, but there are probably more out there. There's the ethnic power relations dataset family, and the VDEM codebook has a number of indicators that measure the way ethnicity may determine things like access to justice and various other social indicators. So, in quick summary, we had a chance to explore these things. Our team's recommendation is to use some form of panel analysis to study the relationship between racism and emissions at the global scale, to use better parameterization of studies than many studies in the past, and to use racism metrics rather than diversity metrics. Further study in general towards including the effects of racism in scenarios is also recommended. And I hope this talk encourages conversation towards the steps that need to be taken to include racism as a driver in scenarios, or at least explore the relationship between racism and emissions. And here's my contact information. Please feel free to reach out. And thank you all so much.
Any short technical questions to Haley? No, she will be around later on for this sort of conversation we have in the end as well. So I'll leave the floor to the next speaker. It's Nicole van den Berg, and she will give a talk on pathways towards low carbon lifestyles. Let's see if I can get this working.
Yeah.
Yes.
Thanks. All right. Hi, my name is Nicole van den Berg. I am a PhD candidate at Utrecht University. And we've been working on creating sustainable lifestyles, but also looking into generally how lifestyles can be incorporated into integrated assessment models. So this research is about the quantitative side of these scenarios. We also have a qualitative side, but I'll be presenting on the more quantitative aspect. And it's titled Pathways to Sustainable Living, the Impact of Sustainable Lifestyles on Long-Term Emission Scenarios. And these are just our collaborators on this research. So just a bit of background here. So we had the qualitative scenario narratives that are key to this research, and our quantitative scenarios as well. And we look at answering the question of how can lifestyles change, and what impact do these changes have on transport and residential emissions. So on the qualitative side, we looked at workshops with a range of different experts. We also had some focus groups with policymakers to really inform on these qualitative narratives. We had a development of these narratives in this part of it. And then on the quantitative side, we had a review of scenario inputs that was essential to really identify the scenario inputs. And we presented this to the range of experts as well. And then from this, we had our quantified scenarios. And so, of course, these scenario descriptions on the qualitative sides and the translation process will get our scenario impacts, and this was a bit of an iterative process back and forth. So to focus more on the qualitative side here, just a little bit of a short description. We had 2 scenarios that we developed, or at least developed in the quantitative sense. So that's why I'm showing them here, but we actually developed 2 other scenarios as well. And these are Designed World, which is sort of your, bit more tech type scenario. And this is sort of sustainable lifestyles by default. It's enabled by government and technology that play a big role in sort of shifting consumer preferences and shaping citizens to be more sustainable. And then our pocket lifestyle scenario was more on this idea that you have cumulative peer-to-peer impacts and that people, it's more bottom-up decisions to spread sustainable lifestyles and behaviors also through digital technology. So we developed from here, we developed this, I won't describe it in too much detail, but just to show, we looked at this on numerous levels. So on society, which is sort of the inner circle there, or the inner triangle, I guess. And then the enablers, we looked at these different factors that contribute to that. Then on the lifestyle level, which is sort of cross-cutting the domains. And then we looked at behaviors, which are looking really into the domain side of things. And then just to highlight, in case I hadn't mentioned that, but we used image model to quantify this. So we decided that we were going to first identify the different scenario inputs. So this was more on the quantification process, and that in the scenarios we defined our actions, our motivations, the contextual factors that affect the behavioral actions, the adoption rates we distinguished between global north and global south, and also the speed of transition. And this all played a role in how we modeled it. I won't go into too much detail because there is a bit of a longer list here, but I just wanted to show you that these are the behavioral actions that we modeled, and the level of adoption rates and speed of transitions, just to give you an indication that the contextual factors and the motivations is what sort of determined how quickly and how many people would actually adopt these types of behaviors. And then the same on pocket lifestyles. These are the behavioral actions that we took into consideration. A little bit more on the telecommuting and, if, for example, in residential, smaller household size, etc. And then I just wanted to highlight here, because this is sort of essential to the way that we modeled these lifestyle changes, that we looked at these in terms of the adoption rates, the percentages, but also the transition speed. We actually used these adopter groups, and we identified saturation years in which these adopter groups would be sort of saturated. And this was based on this figure here. It's actually by Rogers et al. It's the diffusion of innovation theory, and we adapted it a little to include this sort of time of saturation, and by doing that we were able to actually put it into the model quite effectively. So yes, we use the timer energy model for this as part of the image integrated assessment model, and we actually added these adopter groups as an extra layer of heterogeneity into the residential sector in timer. So it wasn't just something that we did exogenously, but it was able, by creating these adopter groups in the model, we were able to capture these effects. Just some preliminary results. I won't go into too much detail here. This is just transport and residential as a whole to see the different scenarios. and how they compare to each other. And we distinguish here between the solid line global north and the dotted line is global south. And these are all baseline scenarios. So the SSP2 scenario we use as a reference here, Design World in purple and in orange Pocket Lifestyle. So you can see the strong effect, especially of the Design World in transport and in residential. And what's interesting to note, I guess, is in the Pocket Lifestyles, the sort of gradual transition you see, and that's mostly because of the way that we implemented these adopter groups. So I just show you these. So that was on a per capita level, the emissions per capita, and then now we show it on a total emissions. And I show you here for the 3 different scenarios. Basically, what we show here is a decomposition of the emissions and the contributing factors to these total emissions between 2015 and 2050 in this SSP2 scenario. This is for transport, and you can see the different colors represent the different modes of transportation. The letters there represents P is population, A is activity, M is mode shift, E is efficiency, and I is CO2 intensity. You can see here, yeah, I mentioned that already, but it's between 2015 and 2050 and the changes over time. And this is for global north that we're showing. And you can see here that this trend of increasing emissions from population and especially activity changes and reduction in emissions from technology, so efficiency and CO2 intensity. Just to show you on the other scenarios, so these are the scenarios that we developed. This is all in relation to the 2050 result of SSP2. So you can see here that's what it's sort of representing, and that they match up with the values of 2050. So that's how you can read these scenarios. What was interesting is that in Design World, which sort of corresponds to the narrative, you see most of the changes in emissions is from efficiency and CO2 intensity, quite strong effect there. Whereas with Pocket Lifestyles, we see bigger changes in more on the activity side and mode shifts. So that was just an example for Global North, but we also, we also did this for residential. So that's shown here. And the different colors represent the different energy services within residential. And I'll just quickly highlight here the same trend. Sorry, it's a bit small, but in Design World, again, we see it most of the changes within the technology side of things, so more on the efficiency and CO2 intensity. And this is largely due to electrification. And for Pocket Lifestyles, we see it more in the activity and shift, so reduced travel, but also mode shifts as well. And then we did this for Global South as well. I don't have too much time to go into detail, but if you have specific questions, I can come back to it. I just wanted to highlight that there. And then just to come to my conclusions and a bit of a discussion, so we see from our Design World emission reductions that there's about a 38% reduction in Global North and 27% in Global South. For residential, 13% in Global North and 7% in Global South. And that these, in Design World at least, there's a strong tech-related lifestyle changes that we see in the results. And then in Pocket Lifestyle from the emissions reductions, we see for transport 12.5% in Global North and 27% in Global South. And for residential, 8% in Global North and 5.4% in Global South. And here the opposite, that there's more emphasis on consumption-related lifestyle changes. And yeah, just to sort of a limitation here, of course, we're only focused on transport and residential, but we could explore this because food is, of course, very relevant and material demand. So this is something that we plan or hopefully plan to explore in future work. So something that we found really important was the changes in assumptions for equity, so that we have some sort of a distinction between Global North and Global South. But also, if we look at the way that we model residential, for example, we have these different income quintiles and a distinction between rural and urban. So we are able to sort of adjust our assumptions so that that higher income quintiles, at least, that they are able to reduce more, or that there's a certain cap on floor space per capita that only affects people with really high. So we actually noticed that in our results as well. So that was important. We do note that, of course, there's the way that this is modeled is that there's still a large burden on poorer households and on Global South. So that's something that we should pay attention to and be very careful of. And in terms of model development, so I mentioned before, we have these adopter groups that we've implemented. I think it's important to sort of try find ways to implement this a bit better, maybe also expand it to transport as well, at least endogenously. And we have talked about ways of having a designated lifestyle module, so not working in the sectors, but rather having a separate place where there's lifestyle elements that you can change and play around with different parameters. So that's my presentation. Thank you.
Thank you, Nicole. Please also come up, Haley and Johannes, and then we do a very short panel discussion. We have to leave quite soon for the plenary. We'll start sort of 6:15, so perhaps we can have questions and discussions for about 5-8 minutes or something like that. So perhaps we can start with 3 questions, and then you can answer as a group. So I think you were the first asking.
Hi, thanks for your talk. I wonder a little bit about the global north, global south divide, and also how you identify the different adoption rates. So maybe you could talk a little bit about this.
So the next question, any more? Yes.
Thank you. I'm Stefan from the University of Freiburg, Germany. Especially my question goes to Nicole, but also in general. You talked about behaviors and I'll say it differently. I think we need both. We need the pockets, these are the early adopters, and we need to design the system around it. So why do you separate it? Is it not smarter to combine both the infrastructural change? In the session this afternoon, earlier this afternoon, we put next to behavior the concept of practices, right? It's behavioral in a context. So I wonder how more systematic your scenarios maybe could be.
Any more question? No. So we go to the panel. We can start with Nicole, and then Johannes can answer afterwards.
Yeah, so in terms of the global north, global south divide, so we made this distinction, of course, in the regions. We have these in the image region, so it was easy to apply it. When we sent our review out to a range of different experts, we put in these differences, and we basically looked at, first of all, what we already see in the differences between global north and global south, so taking into account the sort of reference, but also to take into account what is realistic in terms of reducing emissions for different regions. So, of course, there's a huge distinction between electric vehicles in global north, where infrastructure, it might not be as possible in global south, and it is quite expensive. So we take that that distinction into account, where we see what's realistic and based on a range of different experts. So that's how we try to, as best as possible, to take that into account. And then in terms of your question, so we agree. I mean, we have these actually 4 scenarios, and that in the real world, or the ideal world, it would be a combination of different elements. I think for the scenario work, it was important to keep these separate, to see the isolated impacts, so we can say, okay, this is that contribution. I think ideally what you would have afterwards is sort of a combination where you can see what the combined effect would be. We haven't done that. I'm not sure if we were planning on doing that, but at least to acknowledge that also the real world is not going to be 1 or 2 of these. It's not one or the other. So just to see the combination, or imagine the combination effect, but for purely seeing the results of it, it was more interesting to separate them, to see what the and I think especially for policy, just to be able to say, okay, what's the if we were to stimulate these kinds of behavioral actions, what would the emission effect be? That was important.
I can maybe add to the question from Stefan too, that like it was actually one of the things that I wanted to get out of the work that we did, to show the impact of lifestyle changes or behavioral changes in combination with like society shifting, to put it in context. But obviously this was a very short project, so we have more things that we could do. And I think one issue that's important is rebound effects, to like actually, especially at an individual level, to see where the money is actually spent if we shift lifestyles and reduce demand of things.
Yeah, and with behavioral changes regarding racism, it's really going to depend on the conjuncture that you're analyzing. Which country you're looking at. In the United States, we've seen policy shifts in policing, the end of stop and frisk in New York. Kind of region by region. Shifts in the way education is handled, shifts in public finance, shifts in, transportation finance, that has, helped alleviate sort of differences in affluence and civil liberties between ethnic groups. So kind of thinking about how this, could be treated as, a lifestyle change as well as something that our team at least just thinks should be, watched as a driver, could definitely play into these analyses.
Thank you. There is definitely a lot of research to do on heterogeneity within societies and political power among various groups and lifestyle changes and so on. So I think it's a fruitful path for research in the future for the scenario community. Now we have to end this session because due to the plenaries. So thank you all for participating in these sessions, and also